All right, today is the last part of section 8.2. We've covered what a sequence is. A sequence is just a list of terms. We've covered that a series is when you add up those terms. And we've learned two formulas so far. Remember, we have the formula that looks like this. This is when you want to find any specific term in a list. And then if you want to add up the terms, this is the formula you use. And again, these only work for arithmetic sequences and series. Soon we will talk about geometric sequences and series. Those will have different formulas. And then we'll look more generalized at other patterns out there. So far we've only been focusing on patterns where you're adding the same thing each time. Okay, so what we're going to focus on today is what's called sigma notation. It involves this Greek letter sigma. That's a capital Greek letter sigma. There is a lowercase sigma. It looks like that. If you have any statistics courses, you will see that quite a bit. So that's lowercase sigma, uppercase sigma. All that means, all that stands for is the sum. It just symbolizes, hey, we're going to be adding stuff up. So here is a very, very generalized view of what this notation might look like. So we've got the sigma, which says, hey, we're going to add stuff up. The stuff on the bottom here tells us where we're going to start by plugging in what number. So here we're going to start by plugging in a 1. And then we're going to keep plugging in successive numbers until we get up to the nth number up here. And then we're going to add all those up. So if I plug a 1 in here, I would have a sub 1, that'd be my first term. Then I plug a 2 in, a sub 2 is my second term. Then I plug a 3 in, a sub 3 is my third term. All the way up to plugging in some number n, that's my last term, and I add them all up. That's all it's saying. It is a little intimidating looking, so I just want to walk you through how you can find the sum the long way and the short way. Okay, so if I was to do it the long way, I would take this equation and I would start by plugging in a 1 for k. So if I plug a 1 in, I'll have 2 times 1. Then I'm going to plug a 2 in, so I'll have 2 times 2. Then I'm going to plug a 3 in, 2 times 3. Then I'll plug a 4 in, 2 times 4. Then I'll plug a 5 in, 2 times 5. And that's where I stop because the top number is a 5. So I start by plugging in a 1, I end with plugging in a 5. And then the summation symbol, the sigma, just means I'm adding them all up. So I would have 2 plus 4 plus 6 plus 8 plus 10, and I would add all those up, and that would give me my final answer. Okay. Sorry. So if you add all those up, what do we get? We get 6 plus 6 is 12, plus 8 is 20, plus 10 more is 30. We would get 30 for our sum. If you look at the terms 2, 4, 6, 8, 10, this is arithmetic. They're going up by 2 each time. So if I am summing up this number of terms and it's arithmetic, I could use this formula right here. I just want to show you that that would apply for this problem. If I think about it as a list of numbers, that is a sequence, and then if I think about adding them up, that is a series, and this is arithmetic because I'm going up by 2 each time. There are 5 terms, so if I want to find the sum of those 5 terms, I would do 5 divided by 2. My starting term is a 2. My ending term is a 10. Okay, and then if I take 5 halves, which is 2.5, and I multiply that by 12, I will get 30. So I can do it the long way. Now this isn't super long because there was only 5 terms, I can do it the long way, or I can use this summation formula as long as I know it's arithmetic. Well, everything we're going to do today is arithmetic, so you'll be able to use this formula. So let's look at a couple more examples. Sometimes the hard part is figuring out how many terms there are. So like in this particular problem, I could list them out and I could count, oh, there's 5 terms. You might also notice that if I'm going from 1 to 5, that would be 5 terms. So in this particular problem here, we're going from 1 to 36, so that's 36 terms. The problem comes with problems like this down here when you're going from 20 to 50. A lot of people think that this would be 30 terms. It's not. I can see why you think it's 30 because you're doing 50 minus 20 in your head. But remember, going back up here, this is 36 terms. Well, if I do 36 minus 1, that'd be 35. But I know there's 36 terms. So doing top minus bottom is not how you figure out the number of terms. Think about, let me just kind of go off topic, well, staying on topic, but giving you another example. Let's say if we were going to go, okay, I'll give a little example here. N equals 3 to 10, and I'm just going to have an N. So I'm going to start by plugging in a 3, then I'm going to plug in a 4, then a 5, then a 6, then a 7, then an 8, then a 9, then a 10. All right, how many terms are there? Are there 10 minus 3? Are there 7 terms? Let's count them out. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 terms. So if you want a quick little rule, you can do the top minus the bottom, but then you have to add an extra 1. So if I do 10 minus 3, I get 7, add an extra 1, 8 terms. That works for any of these. So I can do top minus bottom. 36 minus 1 is 35, but then add on an extra 1, there's 36 terms. Same thing goes here, top minus bottom. 50 minus 20 is 30. Add an extra 1, there's 31 terms. So usually that is right where people make mistakes. They get the wrong amount of terms. Why do you need to know that? Well, if you're going to use this formula, n is the number of terms. So in this particular example here, if I'm going to apply this summation formula, and I can because it's telling me to sum up stuff, then I need to know how many terms there are. There's 36 terms. Okay, now I need to know the starting term and I need to know the ending term. Just reminding you of what these stand for. So this is your starting term. This is your ending term. Okay, how do I figure those out? Well, here is what I start with. My starting term is not a 1. My ending term is not a 36. It's what I plug in. I plug in a 1 into my equation to get my starting term. So if I plug a 1 in there, 5 times 1 is 5, minus 3 is 2. That's my starting term. To get my ending term, I plug a 36 into the formula. 5 times 36 minus 3 is 177. Okay, so these are what I have to plug into the formula. Down here is what I plug in to get my starting. Up here is what I plug in to get my ending. And then I can type this in my calculator and I get 3,222, and that's my answer, and it's super fast. Okay, here's the long way to do the problem, and you'll quickly see why you would never want to do this. The long way, I'll try to squeeze it in right here, would be if I start by plugging in a 1. So I'm going to use a different color so you can see this. So I'm plugging in a 1. And then My next term is when I plug in a 2. So I plug a 2 in. Then my next term is when I plug a 3 in. Then my next term is when I plug a 4 in. Okay, and how far do I have to go? I have to keep doing this until I plug in a 36. No one wants to do this. Okay, I mean, it's possible. It's not like it's hard math, it's just tedious. I don't want to sit there and plug in all those pink numbers from 1 to 36 and then simplify, and then add them all up. Okay, I mean, you can, it's just a huge waste of time. So, since we are summing these, that's sigma, I can use my summation formula. And this is arithmetic. I can prove that. The first term would be a 2. The second term would be a 7. The third term would be a 12, right? The fourth term would be a 17. Do you see how these are increasing by 5 each time? So the common difference is a 5. This is for sure arithmetic. So I'm just going to use the summation formula here, and that's going to make it so much faster. All right, let me see. Oh, that's not going to work. I'm going to erase this and just move it a little bit because it's kind of in the way. Okay, so we're going to do this next problem down here. So remember how we decided that this was 31 terms? Again, the little rule, if you want to use it, is top minus bottom plus an extra 1. Maybe I'll write that down. Number of terms is top minus bottom plus 1. Okay, so there's 31 terms. So knowing that, I'm going to use my summation formula. I'm going to do 31 divided by 2. I need my starting term and I need my ending term. To get my starting term, I'm going to plug in a 20. Okay? The starting term's not 20, it's what I get when I plug in a 20. So negative 3 times 20 is negative 60 plus 31. I'm going to get a negative 29 for my starting term. Now I need my ending term. I get that by plugging in a 50. So if I do negative 3 times 50 plus 31, I'm going to get negative 119. That's my ending term. So now I can throw this in my calculator and I'll get a negative 2,294. So it's just a much faster way to find the sum rather than having to write it out the long way. That's it. So you've got another Google form to work on today, and I hope you guys have a good day. Come to office hours if you have any questions. Bye.